Hey, this is Daniel Chen, and this is my Choose Your Own Adventure Lab. So for my problem, I decided to model the solar system in VPython. And can you accurately predict the length of a day, month, and year on Earth? So the main result was that because Fnet is equal to the force of gravity for all of the planets, we can use the momentum principle to update their positions and create a working model of the solar system. And accurate predictions of time spans on Earth are a direct result of this model. Alright, so here are the concepts applied. First off, we have curving motion. So when the path of an object curves, the object's momentum is continuously changing. And next we have the momentum principle, and from that we can conclude that if the object is moving along the curved path, then it must be subject to a non-zero force. And that force is the gravitational force with the formula and everything given here. Okay, so now I'm just going to run through my program. So first off, we create all of our objects in the solar system, and I also include a scale because otherwise the planets would be too small to see. Here's where I create the trails behind the planets to show their paths. Here's a bunch of initial data, the mass of the star and planets, the initial position of the star and planets, and the initial velocity of the planets. And all this information is from this planetary data chart given off of WebAssign. So anyways, back to this. Then we go into our loop, and delta t is set at 1 Earth day in seconds. And for the loop, I created a function that updates the position of all the planets, and then here's where I implement it. Everything is updated, and here's where I calculate the rotation of the planets. I mostly only focus on Earth, and Earth should be pretty accurate to where one complete rotation is 1 day. For the rest of the planets, most of the rotation is just relative to the Earth. It's not completely accurate because that would be too complicated. And finally, we update time. Alright, so now I'm going to run my program for the equivalent of 1 year on Earth, so 365 days. Which means that the Earth should just make one rotation around the Sun and then stop. I'll zoom in real quick so you can see it. There's Earth right there spinning around, which means that it should stop right where it started. And keep in mind that the planets are 2,500 times bigger than they actually are, and for a sense of scale of the solar system, this is Neptune all the way out here. Alright, so there's the Earth, it just stopped, so that means it just, went around for 1 year, and a day is just equivalent to when it spins around once, and a month would just be 30 days, so that would be, right around here, and every quarter mark would be the equivalent of the end of a season. Alright, so that's the end of my video. Sorry if it was a little too short, but really not too much to talk about. Thanks for watching.